In this video, we are going to discuss example 20, which involves the integration of secant x raised to an odd power of 3. The method to perform the integration for secant x raised to a power of 3 is quite similar to the integration of cos raised to a power of 5 in example 18. Both integration involve an odd power. Both example 20 and example 18 have a similarity in the method of their integration. In both cases, you will have to break the odd power into the product of an even power and a linear power. Then you have to apply the identity to simplify the resultant integrations. Let us look at how we perform the integration for secant x cubed in more detail. To begin, we will break the integrations of secant x cubed into two parts, secant x and secant square x dx. The integrations has to be then carried out using the method of integration by parts. The expressions of these integrations in the language of integration by part is identified to be u dv. We would then identify u as secant x, dv as secant square x dx. We proceed by expressing the integration of u dv as a product of uv minus integration of v du. So let's proceed to obtain what is du and v. Here u is secant x. The differential of u is secant x tangent x dx. dv is secant square x dx. v is obtained by integrating dv, which is the integration of secant square x, and that will just leave you tangent x. Integrations of secant square x is tangent x. So now we have expression of v and du. Then write down u, which is secant x, v as tangent x. Integration of v du is written here. This is for v term. Du is just this. So let me write down the integrations of secant cube x dx. Now you see this is our integration, and it is now expressed as secant x tangent x minus the integration of this term. So let us proceed further. This line is just secant x tangent square x. So the integrations can be further simplified by using the identity that will relate secant and tangent square x. The identity that we have to use is the identity that relates tangent square x to the secant square x. This is the identity to use in order to simplify the integrations of secant x tangent square x. Replace tangent square x by secant square x minus 1. Break down this integration into two parts. The parts of integration of secant x minus integrations of secant cube x. So you see on the left hand side you have a secant cube. On the right hand side you also have an secant cube but with a minus sign. Bringing this term to the left, you would have a factor of 2 in front of the integrations of secant cube x. And what is left is secant x tangent x plus the integrations of secant x. The integration of secant x has to be referred to the example 7 in module 1. In module 1, example 7, we have already worked out what is the integration of secant x, and the result is the log of secant x plus tangent x. By making use of that result, the integration of secant x is simply the log of secant x plus tangent x plus an arbitrary constant. I then move the factor of 2 from the left to the right hand side. Then I will have a factor of half here and a factor of half here. And this is then arbitrary constants. We have come to the result of the integration of secant cube x, which is given by this expression. As a conclusion, we have shown you how to perform integration of secant x raised to the power of cube. The first thing is to break the odd power into the product of an even power and a linear power. We then apply the integration by parts formula to this integrand, where we identify u as secant x, dv as secant square x dx. Carrying out the algebra using the integration by parts formula would then allows you to express the integration into the form of an expression that involves the integration of secant x tangent square x. At this point, you then have to translate tangent square x into the expression of secant x using the identity, so that this integration is expressed into the product that involves only secant x. The substitution of the identity into these integrations results in the integration of secant x and minus secant x cubed. You then bring the minus secant cubed from the right to the left and combine with the integration of secant cubed x on the left. You then have a factor of 2 on the left hand side. Then you simplify the right hand side further. The integrations of secant x cubed could then be obtained, where this factor of half is coming from the fact that you are combining secant x cubed integration from both sides of the equation.